everyone that made it to the last talk, all 35 of you. Feel free to move up and heckle. I welcome questions at any point. Obviously, my name's Tim Connor, since it's been up there for a while. I run a small consultancy called Cloud City Development. As everyone else, I'm always hiring, and I live in San Francisco, so I know a bunch of people. So if you don't want to work for me or some of these other people, I can introduce you, and based on, I do a pairing interview, and based on that, sort of say where you might be a good fit. But that's not what the talk's about, obviously. It's about MongoMapper, sort of, which is a lot of fun to use, I'll admit, but I generally advise people against Mongo for most projects, particularly if they think, oh, it's web scale, which it isn't. Use Dynamo, Bigtable, like React is a Dynamo implementation, Cassandra is too. Just write plain log files and then do a MapReduce. That's not a good reason to use Mongo because you can't figure out how to scale MySQL. Bad reason. You pay a bleeding edge tax. You're going to end up having a lot of people who don't know what they're doing versus how well they would know with MySQL as developers and make a lot of mistakes. And the tooling's going to change. There's a whole bunch of reasons. Ask Carbon 5. There's one guy in here about like the bleeding edge tax they've paid on a couple of projects. They will gladly tell you. And it does have a schema. Cliff Moon enlightened me about this. There's sort of a hidden schema it uses to determine how big the rows should be. And unfortunately, when you exceed this and you don't realize it, all of a sudden your gigabytes upon gigabytes upon gigabytes of data all have to be rewritten and resized, and then your website falls over. So I don't count that as web scale. While I was using it on some projects, replication changed twice in a year. 2 replica sets, and I don't remember what 2 after, which again is that sort of bleeding edge tax. It's one of the reasons I didn't for a long time recommend Postgres, because the replication wasn't quite as out of the box as MySQL. I meant we know how MySQL replication works, and it just does work. That's kind of important for building big sites. Call me crazy, but oh yeah, and they revamped MapReduce. So of course, if you have a lot of data and you're doing big data, you need to do MapReduce on Mongo. And to have them say, oh, by the way, you can't use it that way anymore, rewrite all your stuff. Again, bleeding edge taxes. Using the coolest, oh my God, we all have to use it tech sometimes sucks for a couple of reasons. But, so why would you use it? Well, 10gen, in their defense, are awesome and responsive. You go jump on IRC or somewhere, and they will like tell you why something does it the way it does, and possibly fix it immediately. So that's kind of big. And it's powerful. I mentioned that before in my slides. I didn't say it. What do I mean by powerful? Well, not having a schema is huge. I mean, obviously, we hear about no schema, and why is this such a big thing? Because you can dynamically define your schema in the code. And this is important because it leads to a really cool pattern of development that, yeah, I'll get to that in a second, which is a combination of embedded documents is another part of it, and what you can do with mixins. I thought this pattern that I'm about to get to, I mislabeled it originally composition over inheritance, and I was wrong, and Brian Airy corrected me and said, no, that's not composition, that's just mixins, you dumbass, and thank you, he was right. He said it much nicer than that. So mixins, I'll get back around to, are very important because the inheritance usually when you're building a Rails app kind of sucks. Like single table inheritance, I think everyone knows, is a really ugly approach to solve this problem, but it's your only real choice if you're doing active record. MongoMapper has the same thing called single collection inheritance, and again, it's less than ideal. So, as I said, mixins. What mixins enable is, I would say active record is a good fit for SQL, for having a schema stored in the database. That's what the active record pattern is for, of, hey, look at your database, here's the schema, let's create a domain around it. Data model, not a good fit for active record, or for SQL. Like DataMapper was a cool project, but to define your schema in the code and then again have it defined in the database, not such a good fit. It doesn't really fit the dynamic nature of DataMapper, which NoSQL does. Embedded documents, I mentioned. If you don't know about them by now, I think everyone's heard so much about Mongo that maybe everyone in the room already does. They're kind of like the serialized hash from active support, but like seriously plus plus. If you're using Postgres, people will say, hey, we have native arrays, which are cool and powerful. You're right. They're not quite as cool and powerful as embedded documents. Here's what embedded documents do. It lets you have a whole object that is embedded in another one. So it's like a collection, but it lives on the parent document, which, why would you want to do that when you could just have a relation like in a database? It cuts out a bunch of joins. And so if you have a truly contained sub-object, there are some serious advantages. All the associations work the same, but you can do stuff like this without even a join where, hey, find me all of the people where their address city is in Chicago, and that's blindingly fast if you have things indexed right. And it's just, if you use them a lot, you discover there are some cases where actually it's not a one-to-many in the usual sense. It is a truly contained object. It just works a lot better, and it's kind of cool having support for that built into the data store. But again, mixins. And these sort of get related, you'll see in a bit. So yeah, I know having instance method, class method, pattern from active support is dumb and bad, and we hate the pattern, but it's pretty ubiquitous and it is convenient. So everything in MongoMapper is implemented as a plugin, which is just an active support concern, which means you have class method, instance method, and a configure hook to plug it in. So what this lets you start doing is, instead of using single inheritance, you can have a mixin. You can say, hey, let's define addresses in a couple related fields and dynamically mix them in to any other model. So you can have companies and people both have addresses. So instead of having some weird glom together single inheritance chain, you can say, hey, there's a whole bunch of functionality grouped around has addresses that we can define as a well-encapsulated module, which includes, as we know about encapsulation, both the data on the object and the behavior. And that's something that's kind of really hard to do, honestly, in a SQL database and active record. But it's trivial in MongoMapper, and it's about the coolest thing you can do in MongoMapper. Downside of this power is you have like 50 ways you can do any domain model. In SQL, really, there's like one true way. If you've been building sites for a while, you sort of know what third normal form is and a good way to abstract it, and there is sort of almost one proper way. With the trade-off of embedded documents or not, they're a relation, you end up having a lot of choices. Decide when to embed is complicated, and it'll take you a while to figure out where the trade-offs are. And if there's a lot of trade-offs, that means you're going to get it wrong a lot, and you're going to refactor. And what does lots of refactoring mean when you're dealing with big amounts of data in a non-SQL data store? Well, it means you have a lot of different data versions. And I hate to break it to you, but there's no magic data validity unicorns. If your data exists in 6 different versions, you're fucked. Because you can't really code against an undefined data schema. It's hard to write code that you're like, well, if it was written like a year ago, it probably matches this pattern. But if it's written now, it sort of fits like this. And that leads to completely unmaintainable code. Trust me, I've seen it. You can do long-running feature switches where you're like, oh, hey, if it matches this pattern, then we have to act this way on it. And if it matches this new structure, we have to have this other implementation. But if you start having like 50 feature switches in your code that are all there for 2 years, you have a giant mess of every method takes like 6 flags of knowing how to behave. So there's a solution, which is, hey, maybe we should have our schema defined in one place, which is the code, and there should be one version of that. Which means you're going to have to come up with a way to migrate your DataMapper stuff. And please, if you disagree or have a question, shout out. This is a small group, so we can afford a little heckling. Yeah, you actually need them. You don't just need them for MongoMapper. The title's misleading. You need them for any time you're using Mongo, which really is any time you're using NoSQL. I mean, you have this problem. People say, well, what about React? Same problem. If you don't have a defined schema in your database, you're going to have the issue of your data has different schemas in different points in time. And that's really a no-no when you're trying to figure out what the hell to do in your code. Turns out, though, that's really just a problem of migrating data in general. And even in SQL, it's a problem when you have big data. I meant the standard, I think Rails has done a bad thing with RakeDB migrate in a way, and that it's made everyone think, oh, hey, this magically happens that we just can change our schema and everything takes care of itself. If you start dealing with a lot of data, you realize it doesn't work that well. I meant if you're on the exact right version of MySQL 5.1 before they toggled the switch back and forth of whether column renames are fast, it sometimes works. But in reality, if you're transforming your data much at all, you need to take your site down and put up a maintenance page, and that sucks. I mean, otherwise, you're in a state where the database is either locked up or halfway through transforming a bunch of stuff. So doing in-band large migrations of data is just a horrible pattern that the simple approach to building a vanilla Rails app leads you to be like, oh, hey, migrations are free. We just do them and they run. Well, that's bullshit. I think there's a silver lining that I discovered to like having to solve this problem a couple times in MongoMapper, and that's that you end up doing it right. Honestly, there's one way to do it, and y'all can think about it in about 5 minutes and come up with what it is. Whoa, that slide was supposed to be broken down like that. Hey. I forgot to delete one. So you have to deploy code that writes to both structures, your old one and your new one. You got to use finders against the old one because until you have all the new structure written, your finders against the new one won't find all the records. You got to update them over time because you have a lot of data, and if you do one big migration all in one go, it's going to bring your site to its knees. When they're all updated, you can switch to using finders against the new structure because in theory now all of your code, all of your data looks like one way that a new finder can find. And then you clean up the old data structure whenever the hell you get around to it, whenever disk space gets expensive or something.
Stupid question.
Yep.
How do you know, I mean, if you've got billions and billions of records, how do you know when all of them are updated?
Well, that's a good question. Those finders get helpful for that. A little later, I'll mention that it is very useful to have a finder for that purpose, to be able to tell what are updated. If you have an intelligent finder that is like, look for this old structure, or look for the lack of the new one, then you can do a count on that. And Mongo is reasonably fast. And if you have things indexed right, when that is 0, then you're done. The later ones will get into the processing of that a little bit. But
I put a version column, for example, in every all records.
that's one of the things you can do. I don't like the version column because just like the old version column in Rails, it sort of doesn't work with feature development and then getting versions out. It's a little better if it's on each model, but I prefer at most.
Not in a separate collection, like
Yeah.
in each record.
Yeah, you have to do it in each record, yeah. You could also, if you really are obsessive, try to drop your old data at the same time, but that means, again, you have to have Finder that finds based on the new schema and the old schema and do sort of a cross-union join thing, cross-engine join in your own data store, and it just, don't try it. You can do it if you want, but it's a bad idea. So how do we sort of implement this thing? Typically, I mean, as a Rails person, we're going to say, well, we have a before save, and when we load up the record, we do a before save, we transform it in the new version, and then we save it. Turns out you don't need to do that because of a kind of cool trick that's a combination of how MongoMapper is implemented and the fact that Mongo is a document object store. So you're storing the whole object each time. MongoMapper always uses the setter when you initialize. Rails does some different stuff, but if you define an attribute setter, just by loading the object, it will be run through that. So if you have your old way of, there's a bug in this code, if you can find it, points. If your old way of doing it is address and you decide you're adding multiple addresses, if you just have an address setter, just by loading it, this will run in the middle here. And then, of course, you have your thing to make it work with the old way. And then if you save, you're done. There's no before save. Just because you defined a setter and the way MongoMapper loads all attributes through the setter, you don't even need a before save. All you need to do is code to make sure that, hey, if I'm loaded, handle it. Which means migrate becomes you just have to touch and save every record in your data store. which is, not a problem with billions at all, ever. Every untouched, because it's a little annoying if you're dealing with billions and you've updated half the records over time, just letting this stuff run, to then go through and re-update all of the billions again, which is the answer to your question. You really, really, really want a finder for the untransformed records, because you want to be able to say, hey, let's update only half of the billions, not all of them. So the actual migration process went through on a project where I had to build something. Unfortunately, sorry guys, I didn't have time to abstract it out to an open source thing. It was a client project. You could touch every record in like Rails migration and make it work how Rails people expect and be all seamless, which is going to be slow. It's going to kill your deploy. It's going to take a bunch of work to fake. It's going to not have any advantages other than making people feel comfortable, which isn't always such a bonus. Then you say, hey, why don't we do that other hack, which is we make a rake task called rake migrate something or other that we run out of band. At least it's out of band, so now you can do a deploy and then run it. It's still going to be slow. You're not going to have good error tracking. You're not going to know what the status is. It's not going to automatically be timed for you. It's going to be impossible to add additional workers. So after you've implemented that and it doesn't kind of work very well, you say, hey, we all use rescue anyways, or some sort of background job. Why don't we just use rescue? That sounds like a perfect solution. You still have a lot of rows, and you need a way to track progress, though. So just like a rescue worker isn't the solution. I ended up finding a pretty good solution being to, to subclass rescue status and add in some custom logging and outputting of errors. Because you could just do the standard Redis thing and shove your errors into Redis and be like, hey, we have Redis, and there's an error. Why don't we shove it in there? But, oh, wrong order. Damn it. Oh, well. What the slide that isn't there, and I got in the wrong order, is if you shove all of your errors in Redis, your Redis is going to blow up and fall over. If you're talking about billions of records and you make one mistake ever, or you have a little inconsistent data, and personally, I don't like making Redis fall over when I'm counting on it to keep track of which records I'm migrating. So you need to keep track of things a little better. So come up with some sort of cool subclass of status. I found it useful to output log, since, hey, disk space is cheap, just a log file of, say, all the records that errored, or just keep track of the IDs. You're going to hit another problem then. You're like, sweet, okay, so we have this cool rescue thing that's keeping track of what's going on. Timeout false. There's some weird timeout issues with long-running cursors in Mongo and MongoMapper. And I don't remember exactly, but it might have been a case like it wasn't even accepting passing in the timeout, like setting timeout not to be true, which meant you would have something running for some number of hours and then just deciding, oh, hey, I timed out, too bad. So if you implement this yourself, you may have to invent your own batching process, which isn't that hard. But don't count on MongoMapper and or Mongo's timeout, each without timeout or something to work quite how you expect. But one pass-through, I swear to you, is not going to fix all your data. If you hit billions of rows and you try to do a pass-through, you're going to discover that, oh, you forgot a few cases, so you're going to need to be able to do a multi-pass process. Oh, and here's a slide that I thought was supposed to be earlier. Oh, yeah, and call out to the ThoughtBot people. Hop toad is another possibility, because, hey, there's nothing quite like tracking errors in Mongo and shoving it into someone else's Mongo instance and seeing which wins first. What was that?
When it works.
Yeah, when it works. Well, hey, they're on Mongo too, so what can you say? Yeah, so this is great. So now we're not overloading our Redis. We are having one instance running to try to transform billions of records, which you might guess could take a while. So you need some way to slice it up. And the first answer people come up with is, hey, take a mod of the ID, and then we can have 10 workers. And so we divide it up into 10 chunks and then run workers against that, which, God, why do I have to keep coughing? Sorry. Getting over a cold. 10 workers, 100, how many ever. It's not very flexible. It'll get the job done. But there's got to be sort of better ways to do that. One of the other cool things about Mongo is it has a find and modify where you can actually find a record and at the same time atomically set a flag or modify a value. So you can do something like if you have your version flag or some bit of under transform, you can find a record at the same time as you're setting it to be being transformed. So given that, you can make sure that you're not finding a record that a different worker is already transforming. This lets you spin up, and this is my ideal final solution. It's spin up n workers with a randomized finder. So at any point, take like 1,000 out of the chunk for each worker and process it. And since you're setting a flag, you're kind of safe that you're not stepping on your toes. And because of how it's working, all you're going to do is end up retransforming it if you do a little. Yeah?
But that, I mean, that'll work for Mongo, which has some atomic operations. Any Dynamo implementation.
You're going to have to find your own way of doing it.
Yeah,
Yeah, there's another solution, yeah. But this is the cool, supposedly this is a MongoMapper talk, so that is one cool thing about Mongo is that operation. Because then you can say, hey, add 10 more workers when it's off hours. And so then this allows you to transform a large data set where you're like, hey, hit Mongo only so hard during the hours that matter, and at night put 100 more workers on it. Which is actually a pretty cool thing and how we should probably generally be transforming big data in general. Not trying to pretend like, oh, it's just the same Rails solution. One of the other ones, yeah, depending on how big your Redis instance is you could just shove all the IDs into a queue since you're using Redis anyways, and then spin off of that queue. There'll be some interesting timing things of how many do you want to put in there, and it could get complicated, but it would work in the React case where you don't have find and modify. Personally, I'd like to be safe, so I'd still have an instance method that can tell if that flag is set in case my timing is weird, just to not do the work so I can escape early, because it's really slow to transform in Ruby land billions of records, so I kind of like to not waste time doing it. So now you have awesome migrations. I meant, if you do implement this, it's not that hard. The general approach, hey, ping me if you have any questions, because I have done it once or twice. But it's a pain in the fucking ass. Because you're still tracking multiple versions of a lot of data and having code that works around it. And it turns out that you should just avoid it. I wouldn't have more than 1 or 2 big transforms going at once. It starts getting hard to keep track of what's going on, and then something falls over because one of them is interfering with the others. Which means, God forbid, you actually have to suddenly be careful about your upfront design, that you're getting the modeling your data right. Which the funny thing about this is why you went with MongoMapper supposedly was so you didn't have to worry about the schema. And now, wait, but I have to worry about the schema more because it's going to be a pain to transform, and now I actually do have to worry about the schema. So I think it's a little bit of a not such a great trade-off situation there. If you're not dealing with giant amounts of data, it's not as much of an issue, but then you still don't have the, hey, let's just do Rails transform approach. So I have projects I would use Mongo on, but some of this, don't worry about it cost, is totally illusionary. You're just pushing cost to a different point in the cycle, which is 3 months in when you try to refactor something and you discover, oh, this is really hard to keep track of. As I said, talk to the Carbon 5 guys. They've moved a couple projects off of Mongo back to MySQL. When I was at Pivotal, I saw a client there do the exact same thing, where it's Rails people are so fast. Well, that's the end, by the way, the slides. Rails people are so fast working against MySQL. We know what we're doing. You actually end up losing productivity, I think, honestly, generally by using Mongo. There are some specific where, yes, this is actually a document. It makes perfect sense, and I really need the flexible schema that make it worth it. But generally, I've found it's a drain as well as a benefit, so really think twice about it. I still talk too fast and need more slides, so we all get to go drinking early unless there's many questions.
Does it make sense to actually use, for some parts of an application, Mongo, and some parts, MySQL, for example, so I can record?
Yeah, I've considered it. I have a project now where if I went back in time, I would, despite my aversion to new and shiny, use Node and Mongo for one piece and MySQL for the rest. The problem is then you get into that dreaded ground of cross-engine joins. And it is really nice to have as much data as possible in one data store, because then whatever that data store approach for handling joining models or joining tables, as it were, you can use that instead of having to get a group of IDs against one and then pull it over to another one and select against that. And like, we know how to tune MySQL pretty well by now, even aggregate queries, and we can do some cool stuff with that. Or if you're using a giant data store like a Dynamo, like a React, there are ways to work with your data. I found it, usually it's not, for me, a breakdown of the data looks a little different, but the use case has to be different enough. Such as Redis is great as a data store for semi-persistent, non-persistent data, not necessarily a primary data store. Or I use a big table, or use HBase or something, roll stuff up and put it back into MySQL so my main app can use it. Like, there are trade-offs always in your data store thing, and all the proponents of one or the other make it sound like theirs is the be-all, end-all. But I meant enough people write about all the trade-offs. Look at the trade-off of which one and see, does it fit my use case? Not does it fit my model, really, my data model, because honestly, if you've been writing like MySQL apps for a while, you can figure out how to model just about anything in a database.
When you don't have experience with Mongo, whatever, you actually know that the first time you're gonna have a lot of stuff to actually fight with.
Yep. So do it on a toy project first. Like experiment with data stores on your own personal project, not necessarily a client's dime if you're a consultant. Or find consultants that like, yes, we want to do Mongo. You're like, you sure? And they're like, yes. Like, okay, sweet. I'll learn something new. I won't at all be frustrated when I hit my head against the wall repeatedly. Yeah, it's hard if you haven't used it to know the trade-offs, but at this point, Mongo's been around a while, so you can sort of Google and find a lot of people ranting about it both directions. It's a lot of fun to have a fully dynamic schema that is determined by your code, that can be determined at runtime even. That fun has to be tempered with what are the costs of sort of lack of constraint. I mean, we talk a lot in Rails about constraints being creative and like making us solve the problem right, and Mongo is the other direction of like, hey, let's have no constraints and do whatever we want. And I had one project on it that was a blast, but yeah, it was a nightmare dealing with different data versions, which is why I said, hey, maybe I should give a talk on this. I meant to abstract it to a gem, but proprietary code, you can't always get permission to do that when particularly you're done with the project and you can't remember it perfectly. And I don't know that I'm going to write another Mongo app until I have a client that's like, yes, let's put it in Mongo. At this point, I would lean more towards React, Redis, and MySQL or Postgres. Because I meant, Mongo does do a lot of cool stuff, but I don't know if terabytes is the answer. I know some people that are pulling terabytes out of Mongo, just writing flat log files and then using MapReduce to roll that up, because Mongo's just not holding up for them anymore. I meant Mongo works great when either your index or your data fit in memory. It is blindingly fast because it's designed to be better than MySQL at sort of I can fit it in memory, so you can do even unindexed queries against small enough data sets that you can't believe how fast they return. You're like, there's not an index on here. How can you do this complicated query against all these sub-objects and just return it right away? It's blazingly fast at that, which is kind of cool, but that doesn't work. That doesn't work when you have like a terabyte of data anymore. And then I think you need a solution that's built more around replication as its core, such as a Dynamo sort of thing. Cassandra supposedly works now, but I don't know. I've been watched how long people have been trying to get Cassandra working that I'm a little nervous about it. And there's a lot of people that I've talked to who are smarter than me and know a lot more about databases, and every one of them keeps saying, well, why don't you use React? So that's kind of why I'm leaning that way. Was there another hand? Or does everyone want to go get drinks? Okay, go ahead. When people leave, then it's done. So.
How about queries on embedded documents? Are they equally fast? For example, you don't have an index?
Yeah. Yeah, I was surprised at how fast queries against embedded documents worked when they weren't indexed. And that's what I was saying. And I talked to the Tengen guys. They're like, well, yeah, if your data set's small enough to fit in memory, in a dismissive tone. And then I was like, oh, yeah, that makes sense. Mongo does some interesting things about how it loads things into memory when you access a collection, and if it's small enough, it's going to do incredibly fast queries against it. So yeah, throw Mongo on your beefiest server for small data sets, where small is in how many ever gigabytes of RAM you can afford. And it'll work. It'll be great. You won't even have to worry about it. It'll just be like, sweet. I type away at this dumb query, and it returns, and I don't have to think about my joins, and I don't have any problems. And then your data set grows larger than your memory. And it falls over and blows up in your face.
It's not really your data set growing larger than memory, it's your active data set.
Active,
so
yes.
That's the thing, like we have way more memory usage, way larger index size than RAM, but we have no performance issues because that's not the active data set, because typically this latest partition is actually active.
Yeah.
So it's active data set, not all.
Could everyone hear that? He just basically said your active data set is what matters, not your data set. Their indexes even are far larger than their memory, but since they're not accessing all of it, which is a good point. If you fit within the profile of Mongo, it is sort of nice how fast and easy it is. I think there are some costs that are trade-offs there, but I was very impressed at how performant it was for what would be in MySQL stupid hard queries, where it's just like, oh, here you go, here's all those records you wanted. Like, but how are you doing that? They put some thought into it.
Couldn't you, so for example, I don't know, sort the data to multiple instances with, I don't know, 100 gigabytes of memory each sharp, and then query.
I didn't quite follow your question, sorry.
Yeah, so if scanning in memory, certain memory objects are fast enough, couldn't you just sort the data among multiple instances?
You could. I don't know, he might know more because it's been 3-6 months. He was asking about, well, how about just sharding your Mongo then? I was just burned by dealing with replication of Mongo a couple times, and I sort of avoided it and treated it like, sharding's a different problem, but if you're going to the efforts to shard, then you could use data stores that sort of work better with large data. Large data in this case, with how big memory is getting, can mean seriously large data. A lot of the websites we build are going to fit fine in Mongo. I personally don't think it's worth the cost of dealing with a fully undefined schema and not knowing what my data is. It is really nice to know that, hey, at least within certain constraints, the data store is enforcing I know what the data looks like because I can write my code against it. You can't really write code against an undefined schema. So if you spend the effort to guarantee you know what the code is, it's totally worth it. If you're hiring junior, intermediates, or even advanced Rails people that haven't touched Mongo, they're going to be way faster writing code in MySQL often, and so why pay that cost? But not saying don't ever use it. I've used it. It was fun. Fun is a thing where it keeps developers productive to some degree, but you don't necessarily want to pay too many costs for that. But there are plenty of shops that, well, John Noonmaker, who wrote MongoMapper, obviously is using it with great success. Otherwise, he wouldn't have written it and keep maintaining it. That's part of why I like my Mongo experience. Mongoid, my first Mongo project, kind of hurt. Sorry, whoever writes Mongoid, but I didn't like it nearly as much. I think it was the plugin sort of DataMapper pattern that's so baked into MongoMapper, which Ripple, which is the React client, was inspired by. So I haven't played with Ripple, but it sounds like you should have a similar experience using React if you use the Ruby client, Ripple. Yeah, you don't have find and modify, but you have a bunch of other cool shit too. So I think that looks like about it, so we can get out of here early. Anyone? Nope, cool.